Engineering from Delhi University. From Delhi University in 1993, and the PhD degree in Electronics and Communication Engineering from Punjab Engineering College, Punjab University, Chandigarh in 2004. He is currently a professor with Department of Electronics and Communication Engineering, Delhi Technological University, DTU, New Delhi. He is currently working on multiple industry-sponsored projects. He has extensive industry and academic experience. He has published 7 books with the total experience of more than 30 years. He has authored and co-authored more than 200 research articles in various renowned international journals and has a H-index of 24. His research interests include vision, speech-based tracking, machine learning, activity recognition, signal processing, pattern recognition, cognitive radio, biomedical equipment design, and so on. Welcome you, sir. Thank you so much, sir, for accepting our invitation and sharing your knowledge with us. Kindly acquaint us on topic of computer vision. Welcome, sir.
Yeah, thank you very much. Should I start now?
Yes, sir. Please.
Yes, sir.
Yeah, so I'm going to share the screen with you. Advance one person shared at a time. Okay. Multiple parts share simultaneously. Actually, this is through Zoom. We generally operate through the Meet.
Okay, sir.
Yeah, share. Wait. Yeah, desktop one. Share. Yeah, am I able to share?
Yes, sir.
Yes,
Your
sir.
screen is.
Okay, now it's visible?
Yes, sir. Yes, sir.
Light is visible. Yes,
So,
this is in presentation.
yeah, dear participants, yeah, good morning to all of you. And yeah, we got a little delayed. This topic is very, very important nowadays because when we talk about machine learning, we talk about AI, a lot of, such kind of words you might have listened nowadays. And the most of the work, which is related to the AI and ML is fundamentally based upon the vision. Even as a human being also, 99% of the work what we do in our day is based upon the eyes. We measure so many things. We do measurements also using the vision, like how fast the car is running. We comment on so many things, though it is generally you can say, the how do you measure the speed with the vision itself is really, exceptional thing, given to us. So this is all, the basically the fundamentally the computer vision, which relates so many engineerings together. Even the students of mechanical engineering, even civil engineering, electrical, electronics, as well as computer, of course, computers, and many other engineerings, even biotechnology. They now require the computer vision as one of the subject. So let's go ahead. I will go along with some of the fundamentals. And here today in computer vision, I have taken the one of the very important topic called as the tracking. Tracking, now why tracking in computer vision? Let me tell you. Like for example, you attend the class. Now you are not only noticing how the teacher, teacher's hand movements on the board. Okay, if writing little fast, you have to be little vigilant. You have to notice everything little fast. You have to apply more of your brain. When suppose somebody is speaking very fast, you become suddenly vigilant. So it means adaptivity is some of the fundamental issue, is one of the fundamental requirement of any kind of vision. And adaptivity is nothing but tracking. So therefore, I have considered this topic as one of the backbone of the computer vision. So there will be some fundamentals, some representations, and some object detection methods. And finally, we will try to compile everything and make it as an application leading to tracking. So as in general, I start with a lot of applications so that the participants, they feel little motivated when they know more about the applications. Like for example, you can recognize the based upon the gait of the object, you can identify the human and motion based recognition. In surveillance application, you can monitor a scene, you can try to see the suspicious activities. This is one of the very important issue nowadays. Then there is another application of video indexing, and this is common to computer science people as well as for others, but more for computer science people because they need to index the multimedia. Now billions of videos and databases is getting uploaded on the internet and is accessible to you just on the click of the mouse. So therefore, you need to have the video indexing as one of the compulsory part of this. Human computer interaction, gesture recognition, eye gazing, etc., are some of the very important applications, even now being utilized, even in the advanced cars and vehicles which are now available in the market. Just wait for 1 minute. Let me, just to think of some. Yeah. Am I audible? Hello?
Yes, sir. Yes, sir.
Yeah. So then traffic monitoring is one of the very important application. We need to keep the things going on fine in our city, and in the future we will require that these cameras have been installed, but these are CCTVs which are almost I will say only 10% to 20% useful, because they only convey when the things have happened. When there is a mishap, then nothing can happen even before that. So they do only recording, but monitoring in real time and informing in real time is the need. Vehicle navigation is another important issue, and obstacle avoidance, etc., etc. Path planning. So we'll go ahead with some of the images. Now let's get introduced to the images, how exactly the problem of computer vision is going to be, and how is the complexity of the problem. You can see the first image, there is a corridor, and you can see certain colorful lines on the sides and on the front side. So this is nothing but because when you have the various sources of light, those sources in the place of the source can make different shades in the corridor. So those shaded corridors even, these shades will vary when the source of the light is changed. So this means that the spread of the optics is one of the very important issue which we need to understand. You can see a second image. On the right side, there is a hand, there is a watch. There are certain cables, there are certain papers on which there is some text written, and probably some other articles lying over there. This is a very complex, scenario, because in general, when we work on the table, we work like this. So many things are lying over there. Only very, few people, they keep things very neat and clean, and it's easy for the eyes to see their table because it is always neat and clean. But the idea is that in general, the students and in general the people, so many things get scattered and still we recognize. So what is that algorithm which helps us to recognize even under the complex scenario? You can see the bottom images. You can see there is one, person who is running, and this is one of the image of that person. And you can see that the image has been broken up into parts. So this means that the human being, when you try to recognize, is such that its part can be their, body parts can be shown separately in motion, and their motions, they depict different kind of actions. So therefore, this is an articulated nature of the body, and this is one of the best way to represent the body. Now let's go for the fundamental object. Let's start with one small problem. Like, for example, when we call an object, no, what is an object? Object is something of interest to us. Like example is boats on the sea. Now, just try to imagine along with me, you are seeing one boat on the sea, or you are seeing 10 boats in the vicinity of each other. What will be the difference? If you see one boat, you feel little shaky. If you see 10 boats around, you feel more comfortable. The reason is that you are capable of measuring the length as well as the other statistics of the boat when there are many boats. When it is only a single boat, then you are not able to measure the statistics of the boat, and that's why you feel little uncomfortable. Fish inside an aquarium is an object of interest. Vehicle on the road, planes in the air, people walking on the road. So these are some of the examples of the objects and the articles of interest to us. Now let's start working on the problem slowly. I'm dividing this video analysis problem into three parts. I suppose we have in this program, we have faculties, or we have mass MTech people, or means others also. Yeah, can somebody tell me the kind of audience we have? Hello?
Sir, sir, all are the faculty members of different institutes.
Acha, faculty members. Okay,
Sir.
fine, because accordingly I will,
Yeah.
So now let's start, because we have to have practical, and nowadays you must have listened that everything should be taught practically. So let's start with the first practical of the video analysis. And the first task is the detection of the object of interest to us. So it means if we want to track the human, we should first be able to detect the human being in the picture. If we have to detect one single human, let's say Messi out of so many people playing football on the ground, then we should be able to find out how the Messi looks like. And if we cannot detect the looks of the particular player, then we can detect him by his the what he is wearing or the number. And even if we are not able to see it all the time, then through the actions and his way of running and his way of moving the hands, etc., etc., so style. So that becomes an object of interest to us. So remember, this will be the first task for us. Then tracking these objects from frame to frame, because video means lot of millions of frames which you are going to encounter. So in first frame, if you can locate the object, and that also in the minimum possible time, because that time should be a real time, so that it should happen before the next frame comes. So now question may arise, there are, let's say, 30 frames in 1 second. So it's very difficult because your algorithm is taking a lot of time. So you need not take the second frame itself. You can consider even the fifth frame, right? So you can leave the next 4 frames and then consider every fifth frame, third frame, depending upon how much faster in real time you can execute your program and the complexity of your program is. Then analysis of the object tracks. So now whatever object you have tracked, you will do some analysis, some statistical analysis, like, from this place to this place, in how much time, what is the time, and then you can find out the speed also. So, and also you can sometimes find out that you might need to find out the trajectory of an object. So these problems can be solved by at least a simple algorithm in 3 lines. So let's go ahead. So I'm dividing now this task into an algorithm. The two tasks which I'm now assigning are, the first one is that because you have to recognize the person or the object of interest. So there should be some model of the object whom you want to track. So we will form the model. Just 1 second. Yeah. So we'll form the model so that we may identify the object. So this is the initial, understanding of the object tracking. So second task which we need to perform is use this information of whatever you know about where the object was in the previous frame, and then predict about the current frame location. See, uh, just imagine that in a football ground, there is a goal kick to be taken, and there is a goalie and goalkeeper and a person who is going to kick the ball. Now, what happens is, what should the goalkeeper do that time? When I ask people, they say that they need to predict when the person starts running. Then you have to see which way he is, how he is running, and where he is going to kick the ball, strike the ball. And based upon that, the goalkeeper has to fall on either left side or right side. So this is the prediction. Prediction based upon the initial motions, tracking of the motions. So though I have expressed a very complex thing in just 2 lines, but yes, for the students, you need to tell them in a slow manner so that they understand, and they understand that the problem is going to be slowly solved and it is not going to be very tough for them. So that's the reason I'm taking it little in a slow manner. So the second part is the prediction about which way the object will be, which place the object can be in the next frame. Let's go next. Now, tracking, when we are trying to implement this, there can be so many issues, and especially the faculties, they need to find out. They are, many of you must be doing the researches in this particular field. So you need to understand where exactly the problems are, why this problem is so complex. And even when we have so many methods, still the problem requires more solutions under complex situations. So let's write down and understand those issues, those problems. Like, for example, the first one is the loss of information caused by the projection of 3D word on 2D image. What happens is the original word, originally we act in 3D because the word is three-dimensional or n-dimensional. But when it becomes an image, it becomes two-dimensional. So there is a loss of information. So even for the human beings also, this is a loss of information. And it is our brain's algorithm which gives us the depth portion, and also because we have two eyes, and because of the two eyes we can measure the depth of the object, distance of the object also. So that's why we feel little comfortable. That's why the God has given us two eyes. But at the same time, this 2D image has to be seen in the 3D way so that the problem becomes easy to track. Second issue, which can be encountered and is a research topic also, is the noise in the images. Like, for example, there is a person who is running and there are trees on the way. Sometimes the person runs under the tree, then he comes out, again goes under the tree, sometimes behind the people, there is a occlusion kind of thing. So like this, the noises in the images can be from the natural scene. The noise can also be because the person is running so fast and your camera feels that the image is blurred. You can notice this when you sit inside the train, and if you look the nearby areas, just imagine, you must have tried to see when your train is running, let's say Shatabdi or some kind of Rajdhani, and it doesn't stop at every station. And when you pass by some station and you see the people, you hardly can notice. But if you see the far off objects, you can easily understand them, right? So therefore, there is a blurring due to the speed of the object or the camera also. So this also becomes one of the research topic. Then comes complex object shapes and motion. See, somebody is, let's say, child. Child is, you never know. He is walking and suddenly feels like running and he starts running. But the grown-up people, we people, we generally move with a constant speed, right? We don't, in general, if we have to run, we will run. If we have to walk, we will walk. But there will be not a sudden change in that. Object shapes are also complex. So it means understanding the object shapes is also one of the problem of the computer vision. One more thing, non-rigid or articulated nature of the objects. If the object has an articulated nature like the human beings, then the tracking will be based upon the individual parts. It will be more of a activity. And if it is a solid thing, which is rolling or like this, then it is a different thing. So then the problem of tracking cannot, maybe little less complex. Partial and full object occlusions. Occlusions, when somebody overlaps you and you become partially or fully invisible to the person who is keeping an eye on you. So under the occlusion, when you come out of occlusion, then how do you identify that this person is the same person whom I was trying to track? You must have seen so many films in which this happens, that somebody, some criminal, he gets behind the people and over there, and then he suddenly comes out, and then you recognize. Scene illumination changes. Now, I give you one very good example of a, especially the, when you go to the marriage, there is always a dance floor. Can somebody tell me why the floor is called dance floor? Why the normal road is not a dance floor? Why your room is not a dance floor? Why any other floor is not a dance floor? So initially, I also didn't understand this. But then what I did is I was looking very carefully at the disco lights over there. So just imagine that you ask the person to just stand on that so-called dance floor, and then you start the disco lights. Even if the person is not moving his or her hands or not doing any movement, still the person will look like as if the person is dancing. Even if he just, brings his or her hand little up, it looks as if it's a some very, big dancing action, which actually is not. So it means that the illuminations can make the things look in a very different manner. So this is also one of the research problem, how you can, sometimes you need to make your scene immune to illuminations, and sometimes you need to illuminate. So if you have to have the uh, dancing floor kind of situation, that is called, and you want to create it, so it means it is a computer graphics. And if you have to uh, understand the object motion, even with the disco lights around, and that is called as the computer vision, right? Real-time processing requirements is going to be the minimum requirement in the even today also, and in the coming time definitely. So based upon our now knowledge of what all problems can be there, we think that we should put some constraints. We should impose some constraints on the tracking problem because we cannot work in the infinite domain. So we need to impose certain constraints on the problem. Like the first one is all tracking algorithms in general can assume that there is a smooth motion, there is no abrupt changes. So it means that we assume that 99% people they walk on the road and they don't walk abruptly. So this means that the object motion is of constant velocity. So that is the assumption we are making. And third assumption is the prior knowledge about the number and size of the object. So initial knowledge of the how many numbers and how much is the size of the object and its appearance or shape, etc., etc. So some idea about that is known to you. Like for example, let's say the task is given to the cop that you have to identify this person. So the cop is shown the picture of the person whom he has to identify. So at least some prior knowledge is given before giving the task. You give the assignment to the students, but before that you take a class. Or you, even if, for example, you have to give the assignment without teaching, you will tell them how to explore. So, like this, some prior knowledge is very, very important, which is one of the basis for the theory, Bayesian theory. So let's go next. So now, the kind of problems. Actually, I'm trying to generate more problems, understanding more problems. And I have a belief that if we understand more of the problems, if we can identify the problem, then we can rectify the problem. Major issue with the research community is to identify the correct problem. So let's try to, consolidate with more issues. Uh, First one, we identified that the 3D to 2D projection uh, is one of the issue. Noise in the images is the issue. Then cluttered background is the issue. We did talk about the background earlier. So every foreground cannot have a white background or a notebook background. In general, in real life, it's always a very complex background. See the tree, the leaves are already in motion, you are also moving, so it is a relative motion. But their motion is in a particular domain, and your motion is unlimited in that particular viewport. So, therefore, background is extremely important. Complex object motion is what we identified earlier, partial full occlusion we identified earlier, illumination changes in real time processing. Then comes adaptivity. Adaptivity is very important. You can see, I take an example from the this Discovery Channel where there are various animals and some animals means they have to kill and eat. That's only the way they can survive. So in those, if you see that the most confident animal is the cheetah. If he decides, he can capture, and it is really possible that the deer will go out of his reach. And until or unless some other constraint, and it is his good luck which might save because of his adaptive adaptivity, because of his adaptive running, so because of his adaptive thinking. So that adaptivity is an algorithm, right? So tracking is fundamentally an algorithm. Of course, it is related to the weight of the person, weight of the animal also. Like if you see lion and these tiger, etc., they run for certain time very fast, but then they become slow. They cannot run for long and track the animal. So that's why, they have to hide somewhere and they have to catch. So adaptivity is one of the algorithm. Abrupt appearance change. So if the appearance changes abruptly, that makes the object tracking difficult. Leaving out of scene. So if you are coming to the scene in the viewport, then leaving out, then again coming back, how do the system know that it is you, the same person? So should start tracking after a kind of like, the blinking of the eye for, let's say, for 1 second or 2 seconds. Then suddenly, if you, let's say, you go to sleep in the class for a few seconds, and then you come out and then you start listening, and then you suddenly missed many sentences of your teacher, and it becomes difficult for you to, then you ask your friends, okay, what did sir say about this? So like this, so this is a leaving out of scene and situation. Then drifting is another issue. Drifting means that when you try to remove the background, if you do just the frame differencing, you lose on two sides. One is you left some place where you were in the last frame, and you occupied some other space in the image where you are at present. So both the places had the motion. So that's why you become little bigger. The object becomes little bigger in size. So drifting is one of the issues. So that's why there are many this background subtraction techniques. There is a research going on the background subtraction techniques itself. Robustness is one of the major issue. Your algorithm should be robust. Inaccuracies in measuring foreground and background, as I told you. So now let's divide this into parts. The whole research problem of this tracking in the computer vision, let's try to divide it into parts. The first part is the description of the object to be tracked and what all techniques we can use. Now we are understanding the names of the techniques. Like we can consider it as a template, we can consider it as a shape, we can, if we don't have anything else, we can consider it as a texture. We can also consider it as a color, some color we need to track. And in case the one single feature doesn't help us, then we can think of multiple features. ठीक है ना? जैसे for example, you have to identify, the US had to identify Osama bin Laden, and he changed through plastic surgery his face and so many things. But many of the features, his walking, his his styles, etc., person cannot change, because the person has to change the brain also. So that's why they could identify him from the multiple feature fusion. Gradient features are one of the very important features. So these are the maximum number of features through which we can describe the object. You can choose as per your need and the complexity of the problem. Embedding object into certain context. Now, you know that there are going to be constraints, there are going to be conditions. Like, for example, if I take one example of this, let me tell you, somebody got the first job and wants to send a gift to the mother. And there are two ways, One is that he can send the gift by courier and then may not inform. And then, suddenly sometimes, the gift might, reach over there and mother will call you back. Second way is that you send it through the courier and you send the name of the courier and it slipped to your not slip, rather the the day when it is probably going to be reaching over there and the phone number of the courier service over there. So the second method ensures that the gift will reach. The first method doesn't ensure that the gift will reach. So there is a context. So embedding objects into context like a priori knowledge of the context of the object, runtime, how the object is behaving, co-occurrence of many things, spatio-temporal relations of the object, and any other knowledge will help us to generate the context for embedding object. Third issue with us is the drift control. And as I told you, the drifting is a problem. So we need to have a better and better method to control the drift and have a better method for background subtraction also. Then finally, we have to make a decision. So one of the technique used is the Monte Carlo sampling, which includes particle filters, Kalman filters, okay, kind of filters which are used for the tracking purpose, and they include the Monte Carlo sampling. Markov chain Monte Carlo is another new model which is being used because the Monte Carlo along with Markov generates the prior knowledge from the previous data, and the chains, they give us the one-dimensional learning, and that learning is fed to the Monte Carlo to have a better decision. Online learning methods like generative techniques and discriminative techniques are also very, very useful. Also can be considered as part of the Monte Carlo sampling. And then finally, you update the model because it is a continuous process. It's never going to stop. Tracking is something that throughout the life we keep on doing. The moment we get up, rather, even when we are sleeping, then the body is being tracked by the brain always. That's why our heart is always running. So this is now a better algorithm with some methods. Let's go to the first one. So I talked about the gradient features categories, shape, contours, subcontours. So there are so many methods you can note down. the hierarchical chamfer matching, hierarchical tree for part templates, network of contours, edgelet, and maximum a posteriori probability estimation, map algorithm. So these are some of the techniques which are used for getting the shape contours. Then statistical summarization of the gradients. And there are some old methods and some new methods combination of this. The first one is the SIFT descriptor. Second is the Ransack. Ransack is a faster technique than the SIFT, random sample consensus. HOG. HOG is another technique where you use the gradients, and it is a statistical summarization of the gradients. Of course, SVM is a classifier, so but fundamentally it is the HOG which comes under the statistical summarization. Adaptive contour features can be extracted. Contour features I have told you how to extract, but adaptively doing it will lead to the statistical summarization. Oriented granular space. This is a new use of the gradients. Of course, here because it is from the literature survey, so AdaBoost is the classifier which was used. But oriented granular space comes under the statistical summarization of gradients. Huff forest is another example of statistical summarization of gradients. So these are some of the gradient-based techniques, advanced techniques, which can be used. SIFT in short is scale, rotation, illumination, viewpoint, invariant, but it may not be that much, 100% invariant to all these. There are problems, and that's the reason you have a better research. This is the algorithm for the SIFT. You can construct a scale space, sorry, then apply the Laplacian, find the maxima and minima in the difference of Gaussian image, find out the key points, remove the bad points, assign some orientation to the key points, and go along with the key points and go to the next cycle. So this is what happens in the SIFT. Ransack is, as I told you, is a faster technique because you get the ensemble randomly. It is a random ensemble. So therefore, it becomes faster. So you iteratively select some random subset of the data and then a model is fitted to this hypothetical inliers. So model, as I told you, it may be related to the shape, it may be related to the motion, style, and anything. All other data are then tested against the fitted model. Then if you get some points which are really very important in the hypothetical inliers as part of it, then you consider it as a good estimated model because you have a test data and you have a training data. So this happens on the training. Then the model is re-estimated from all the hypothetical inliers. And once it is trained, then it is ready for testing. So these are some of the steps. Even the toolboxes are available for the Swift and Ransack in MATLAB and in Python. HOG is one of the very important method which became very popular, and there are, I think, 30-40 varieties of HOG available nowadays. You can see that you can divide the image, small spatial regions, cells, can be rectangular or radial, depends upon you and your application. And then cell is accumulating a weighted local one-dimensional histogram of gradients. And if you want invariance to illumination and shadowing, then you have to normalize the contrast, etc. Get the local histogram energy to normalize all of the cells in the block. And there is some block diagram which I have drawn over there at the bottom. Normalizing color, get the gradients, get the weighted vote in the spatial and orientation cells, normalize the contrast, then collect the HOGs over each window, apply the SVM as a classifier. So only linear SVM is a classifier, the rest other is part of the HOG. These are the object representation techniques. You can see a single centroid is representing the human being. Set of points can represent the human beings. A rectangle can represent, ellipse can represent, contour can represent, silhouette can represent. And this is articulated shape model. So many small circles and ellipses, rather all ellipses, can represent the various parts of the body. Skeleton can also represent the body. I told you in object representation templates. So here face as a template can be used. And if you find out the probability density of the object appearance, and it can be mixture of Gaussian's technique or some non-parametric model like histograms. You can characterize an image region by its statistics like this. So these statistics will be different from the background, so that's how they can be separated out. This is how the Gaussian distribution looks like. You can see the Gaussian variation by changing the various values of mean and variance. You can see the changes occurring. You can see that the object centered at 1,3 with a standard deviation of 3 in roughly this direction, and of 1 in the orthogonal direction. So this image represents the object dimensions. So this is one of the example. So this is an example of the Gaussian mixture model. I'm just showing you with a simple example through just the looks itself, you can identify this, how the mixture of Gaussian functions. You can see 3 Gaussians, they make a single curve, overall red curve. So the individual Gaussians, if they are separated out, you can get the individual statistics of the curve, non-linear nature of the curve you can identify. So this is one example. That's the reason this mixture of Gaussians is popular to identify the complex video frames. This is how the mixture of Gaussian looks like in 2 dimensions. That was a 1-dimensional. This is 2-dimensional in an image. You can see 3 Gaussians individually. When they mixed up, they made a different picture like this. So that's how and they can be always, the mixed picture can be broken up into 3 Gaussians. Point representation is another technique. Rectangles, ellipses, etc. I have already conveyed you. Feature selection, you can select the color, edges, texture, RGB, HSV, and so many forms, I'm conveying you, and you might be knowing also. Then comes object detection. You can see a complex image. The point detectors point to various changes in the happening in the image. Wherever the change is happening, you made it as a point. So that point can represent the whole complex image. So point detection can also work in some of the complex applications. Background subtraction is another issue, and can be taken up using Gaussian mixture model also. This is an object detection process which we carried on from the standard video. You can see there is a road, and from the flyover we have taken the video, and you can see the car is moving slowly towards the camera, and we are able to track it. This is the background subtraction. Hello. And this is how the cars looked in a noisy background, because if the background subtraction is not very proper, and in that case we get this noise. This is the second set of the video which we had used for testing. This is statistical modeling example of the background. You have an image, and then you try to separate out the human being out of it. So because the background, if is known, or even if it is not known to us, we identify the object, then we can try to separate out the background from the foreground. So there can be a point tracking for when we finally try to track the object. There can be kernel tracking, there is a cellular tracking. In a short period, you can identify the names for planning to do your research. Template matching has many limitations because it is a high computational cost due to brute force search, and it limits the object search to the vicinity of its previous position. Then there is a let's say there is a template direct comparison, template T and candidate G. So you can make the difference in comparison between the two by using these 3 techniques. The first one is a Euclidean difference. It's a difference. And the second is when you take the square of this, like a mean square, because there is a square term and there is a moving average. So therefore, it can be considered as the mean square. And then there is a convolution kind of situation, the third distance. Then you can find out the Bhattacharya coefficient when you compare the two distributions. So this is one of the equation for the Bhattacharya distance. Spatiotemporal features like volumetric features, contour motion features, Hessian detector, multiple feature fusion, which we call in general as a array processing in communication. So that is nothing but the multiple feature fusion. Array processing also uses the concept of fusion only. So these are some spatio-temporal feature extraction based object tracking. Color feature based, if you want to go for, then you can have few methods like spectral power distribution of illuminant. You can find out the spectral power distribution. You can find out the surface reflectance properties of the object. So this is related to the color feature based object tracking. Texture, if you want to find out, then you can go for the techniques like Gabor wavelet. You can go for LBP. You can go for Weber local descriptor. These are some of the latest techniques. I told you the generative techniques and the discriminative techniques. Now I'm giving you the name of the techniques. Generative techniques, which are appearance changes based. You can go for mixture models, expectation maximization algorithms, tensor subspace learning models, incremental PCA, principal component analysis based models. These are generative models. And the discriminative, where the appearance changes during visual tracking. Then you can detect by tracking, means tracking by detection. You can use linear discriminant analyzer, incremental. You can have a SVM, basically it's a classifier, but you can use it for tracking. You can use the attentional visual tracking algorithm. These are called as the discriminative techniques. Monte Carlo sampling techniques, I had given you, now I'm giving you the names. Kalman filter, extended Kalman, unscented Kalman, particle filter. These four are very popular names, and there are many of the varieties of these filters. You can always choose any of them. Eye tracking problem also we tried to solve over here. This is the sample database. Elliptical head tracking using intensity gradients and color histograms. This is how the object was initially separated from the rest of the image. There is another algorithm called the mean shift tracking algorithm. I have mentioned you the paper name also. This is a much advanced as compared to the earlier techniques. Mean shift also has got a lot of varieties nowadays. Okay, so but this can be better because this was published in 2003. So just imagine that how many new varieties must have come by now. Well, this is some of the, some glimpse of the, techniques, methods, and the process which we generally use for the object tracking. And as I told you, object tracking is one of the essential part of the computer vision, one of the basic part of the computer vision, right? So you can now ask me any question related to this.
Thank you so much, sir. Participants, if you have any queries, so you ask. Write in chat box also. I think, sir, there is no query. So thank you so much, sir, for your sharing your knowledge regarding in object representation, object detection and tracking. This is very beneficial for all participants in future. Thank you so much, sir, for accepting our invitation. Thank you so much, sir, for sharing your beneficial